Alright, so we're getting into 7.4, and this is not going to be as long as 7, 2, and 3. It's very similar to it, and we're just going to apply what we learned in 7, 2, 3, and after this you should be able to determine trigonometric ratios using the coordinate plane system. So the only major difference between this one and what we've done before is we gave you the lengths of each one of these line segments, and we gave you theta, or we told you theta, and then you calculated some stuff based upon that. This time we're just going to slap the right triangle on a coordinate plane, and you got to figure out the lengths on your own based upon the coordinate pairs of each one of these points. Alright, so it's actually not too bad. So again, orange, hypotenuse length. Burgundy will be the opposite of the angle theta, and then green will be the adjacent side of our angle theta. So and right now we'll start off our theme with reference of foxtrot. Alright, so foxtrot will be our angle theta. I don't think you're going to be able to see that at all. So this will be, let's do the theta. Theta is right there. Alright, so the one on my color coding is going to be in reference to theta here. Okay, so FL here would be our adjacent length. FL and FH. I'm going to make those both green. I'm just going to draw one line because I think you guys understand that whether it's a big or small, FH, man, this is not greening good. FL and FH are both going to be our adjacent angle when regarding FH. And it's this guy. It didn't turn out green real good, but if I do that, for some reason it came out better. Maybe I'll zoom in a little bit. Okay, so FL. Alright, FL is, you could count the blocks, 1, 2, 3, 4, or you could say it's -2 to -6. The absolute value of the difference between -2 and -6 is 4. Okay, and then for the big triangle, you can count the blocks, or you could be it's 2, but the difference between +2 and -6, it could be, okay, -6 minus 2 is 8. Right? The absolute value is 8. Okay. Alright, so that's that one. Alright, now our LG and RH, that is the opposite sides of these two triangles. Alright, so that's the opposite sides of the triangles in reference to foxtrot, which is angle theta. Alright, so LG is going to be 1 minus -3. That's going to be 4. And then this is going to be 5 minus -3, and this will be 8. Whoops, that's the wrong spot. -8. Alright, so do we have enough to figure out sine and cosine yet? Nope, because we need the hypotenuse. We need the hypotenuse. Right, so if we would figure out FG, this is, we'll say this is Z of the little one squared. And we have the Z of the big one squared. Let me zoom out so you can see what I'm doing. Right, is going to be equal to, and then we have our adjacent, which is our x value of the little one squared, x value of the little one squared, right, because our x is our adjacent, right, plus, or actually it's going to be plus the y value of the little one squared and the y value of the big one squared for our little one and our big one respectively. Oh, don't forget, this is a little bit confusing there. Alright, so we'll plug and chug here. So we're little and big. This is 4 and 4, so 4 squared and 4 squared is 16, and 16, and add those together, that's going to be equal to square root equals the square root of 32. And we'll do some math with that in a second. And this will be 8 and 8, right? 8 squared and 8 squared is 64, right? So 64 plus 64, 64 plus 64 equals 128. So it'll be the square root of 128. All right, so let's simplify that a little. Let's put that into better terms. Right, so if I'm going to, in order to figure out so if I wanted to figure out, actually, so I think I jumped ahead a little. So if I wanted to figure out, so this equals 132, that equals 128. So the z length equals the square root of 32, a little one, and the z length for the big one, the hypotenuse that is, equals the square root of 128. So to simplify those, sorry, but that probably went a little fast for you guys. Simplify that, right? So let's figure out if there are any roots in there. So 16 goes into 32 twice, so that equals 16 times 2, and 16 is a perfect root, right? So we'll pull 16. So square root of 16 is 4. Right? We'll go square root of 4 times 2. So that's going to be, so the FG here is 4 square root of 2. Cool. And then FR, let's see, 128 divided by 2 is 64. Cool. And that is a perfect root. Equals 64 times 2, okay, and that's going to equal, well, 64 squared is 8. That's going to be equal to 8 times the square root of 2. So FR, this longer length of the big triangle, is 8 times the square root of 2. You might see a little pattern going on here, right? Because there's something really awesome about these angles, which you'll see here in a second. All right, so let's figure out the sine of the big one and the little one here. Okay, so I'm going to have to erase this. So if you didn't get that, go ahead and get that now. Or maybe I'll just get out a piece of paper to write it on over top of it. I have some of my mom's really pretty paper here, working on during Christmas break. So here we go. I'll do some algebra over top, right? So figure out the sine of the small and the sine of the big. Remember, the sine, well, remember, sine is opposite over adjacent, opposite over hypotenuse. So the sine, I like to use my burgundy because I'm using the opposite. Sine of theta. Sine theta is 4 over 4 square root of 2, which reduces to 1 over square root of 2, right? Yeah, but that's really, really messy, right? We don't like to keep it square root of 2's on the bottom in the denominator. That's considered poor taste in math, right? So we're gonna multiply this by square root of 2 over square root of 2. Okay, so that means that and that will cancel out, right? And this will be equal to, oh, sorry about that, hold on. We don't want that to cancel out. We want that actually doesn't, we want that to be equal to this. So this will be square root of 2 on top, cross multiplying, I don't want actually that to happen, and then 2 times the square root of 2, so this is the square root of 2 squared, it'll be 2 square root of 2. So the sine of our little guy, it'll be square root of 2 over 2. Okay, now let's do it for the sine of our big guy, right? Sine of our big guy will be, this is the small, this will be big. the sine of our big one will be 8 over 8 square root of 2, right? Again, ends up being that, which we do the math again, it's still going to be square root of 2 over 2. Okay, so algebraically the same. Okay, now we're going to do cosine. Cosine is opposite or adjacent sine theta is adjacent over hypotenuse. The adjacent one is, again, 4, right? It's 4 over the hypotenuse, which is 4 square root of 2, right? Math is identical, right? So it ends up being square root of 2 over 2. And because it's identical, the square root of 2 over 2 for the cosine of the big one as well, right? So that's pretty interesting, right? The sine and the cosine is the same for this angle theta here. Well, that's funny. Well, I wonder what type of situation that would result. What angle would that be where that the sine and the cosine would be identical, right? Well, that would have to mean that the angles are identical. Right, so what angle? Well, let's look at tan real quick. Well, tangent equals opposite over adjacent. Well, opposite is 4, right? Our opposite is 4. Our adjacent is 4. And for our little and our big is 8 and 8. Wow, that's a ratio of 1 to 1. That's crazy, right? This is 1 to 1. Let's use orange, I guess. I'll use purple. I'll use purple because it's just a 1 to 1. That's crazy, right? So that would have to mean that they're the same angle, right? Because the sine and the cosine are the same, right? So what angle would this have to be for these have to be the same, right? If the interior angles of a triangle equal 180 degrees, and the 90 is taken out, that means I got 90 degrees left, right? And if the 90 degrees that's left is divided by 2, right, or a better way is divided by 2, right, so that there have to be, like, the rest of it has to be equal, that means that both of these angles have got to be 45 degrees. Gotta be, right? That's the only way that makes sense. And if you see this and you go like, hey, square root of 2 divided by 2, and I do an inverse sine, you look at that, it's 45 degrees. Or if I undo that and I go square root of 2, if I do 1 and I do the inverse tangent of 1, it's 45 degrees, right? So this is a special relationship for 45 degree triangles, right? It's pretty cool, huh? But you were able to pull all these coordinates. The point of where this all started was pulling these coordinates, these numbers off of the coordinate plane. But I wanted to lead that into something nifty there about 45 degree triangles. Anyway, so let's go to this one. I have ABC, right? So how do we figure out angle A and angle B from angle ABC? Well, we got to figure out at least let's figure out 2 lengths. Right? If we figure out 2 lengths, we can figure out an angle, right? So that's the cool thing about trigonometry. If you know 2 things about a triangle, you can figure out everything else about that right triangle, right? So let's figure out the opposite and the opposite and the adjacent, right? Because those are the easiest things to find out, because that's x and y, right? So Or if you want to use Pythagorean's theorem, you can do that too. Right? But x and y are always going to be usually easy numbers, right? So a, the x value for a, which is we're using our x value was, so we're going to arrange for this, right? So what was I going to do for this? Triangle ABC. So a to b, a to c equals, right, it's going to be 4 minus -3. Right, so we got a 4 minus -3, so the a to c is 7. Right, that's going to be our x value. I'm sorry, that's our y value. That's our y value of this triangle here. Okay, our x value of this triangle is c to b. C to b here for this triangle is, see, 2 minus -4. 2 minus 4, that's going to be 6. That's the x value for this triangle. Right, so if I want to figure out a to b, that's like our hypotenuse. I can do 7 squared plus 6 squared. I take a square root of that, and it's like 9.21 whatever, right? But I'm going to square that back. It's going to be square root of 85. The square root of 85. What's that divided by 5? 17. That's an ugly number, but that's pretty much what I'm going with there. Square root of 85. There's not really anything else I can do with the square root of 85. Okay, so I'm going to stay precise with that. Okay, so this is 7. This is 6. And this is square root of 85. It's like 9 point something. Okay, so what is my angle A? Let's say angle A here, we'll call that theta. How can I figure that out? Well, I can do any number of functions. I can do sine, cosine, or tangent. I'm going to do tangent because I have nice easy numbers to put in my calculator. Right, so I'm going to say sine of theta equals the tangent. I'm sorry, that's way wrong. I don't know what I was thinking. Right. So theta equals the arctangent, right? That's the inverse tangent or the arctangent of the opposite of 6 over 7, right? So 6 over 7 is the tangent. If I put in 6 over 7, that's the ratio. And if I do the arctangent of 6 over 7, I will get theta. The ratio of 6 over 7 is the tangent. So this is how that looks. Right? So if I go 6 divided by 7, it gives me some fraction. If I press second and I press the arctangent, right, you see that? Right, I press second, so it tells the calculator to ignore what the button says and take the input from what the button, the information above the button says. So if I say that, now it says that that angle, opposite over adjacent, is 40.6. 40.6. Right, so now if I know that this is 40.6, I could figure this out another way. Right, I could say, hey, 6 divided by 7 is 40.6. Let me invert that. Right, so now that's 7 divided by 6. Right, so if I do 7 over 6, that is the tangent of B. Right, so I can just do the inverse tangent of that. and that's 49. 49 point, I don't know, like 4, right? And if I did that all right, so I'll put that equals the inverse tangent of 7 divided by 6, right? So if I did that all right, I should be able to add 48.6 plus 49.4 plus 90 equals 180. And once you find one angle, you could have just added them together and subtracted it from 180, and you would have gotten the other angle. There's another way to do that. Okay? Lots of ways to solve. Just got to know your way around triangles. Okay, now I have x, y, and z. My y value, my sine value, if you will, or my up and down value, zy. Zy is going to be 4 minus 1 is 3. That's my y value. Okay, my x value, or my xz, is, let's see, it's negative 2 minus 4. The absolute value of that is going to be 6. So that's my x value. Right? So this is 6 long, and then this is 3 long. Okay, so 6 and 3, and I could Pythagorean theorem that. So 6 squared plus 3 squared equals, take the square root of that. That's 6.7, but that's the square root of 45. So x, my hypotenuse, xy, is the square root of 45, which is 9 times 5, right? So I'm going to reduce this. This is the square root of 9 times 5 is 45. I'm going to take that 3, the 9 out, right? And I'm going to make that 3 times the square root of 5, right? Because if I go 5 square root times 3, it equals the square root of 45. Remember that, 6.708, 45 square root, same thing, okay? All right, so this is the square root of 3 times the square root of 5. Okay, so there we go. Well, this should all have been up here. Oops. So let me go ahead and write all that up there. Zy is 3, which is also y. Xz equals 6x, and then xy, which is 3 square root of 5. This is also my z. This is 6 is also my x. Don't be confused with this multiplying. This is just saying that these are also my x, y, and z values. All right, so to figure out my x value, let's do. I want to do. For figure out angle x. Let me do sine this time. I'm gonna do my sine of theta equals 3 over opposite over adjacent, or opposite over hypotenuse, 3 square root of 5. Okay, right, so 3 divided by 5 square root, that's actually made 3, so on a calculator, 5 square root of 3 times 3 equals, I've got to invert that and multiply it by 3. That's going to be equal 0.4444, right? So the sine of that equals, so the sine of theta equals that, right? So I need to take the inverse sine of theta. So I need to say the sine, the arc sine, well, I need to say theta equals the arc sine of 3 divided by 3 square root of 5. That's 3 square root of 5. That is 3 divided by 3 square root of 5. Right? And so I'm just going to do the inverse, the arc sine of that, which is 26. So theta equals 26.56. So x. So this is 26.56. Okay, so now I'll do a tangent to figure out z, y, angle z here. Well, angle z is 90 degrees, obviously. So let's do angle y. Angle y, 90 degrees. So angle y, that's an error there. Angle y would be, as the opposite over adjacent, would be 6 divided by 3 equals 2. Right? So the inverse tangent so if I go 2 and do inverse tangent, it's going to be 63. 63.4. Okay, so 20 plus, if I do that, plus 26.56 equals, that's 90 effectively, plus 90 equals 180. Okay, so that is, those are correct, right? There's rounding error in there. That's why that's not exactly 180. Okie dokie. So then there's this final one here, 3 triangles. We'll do triangle 1, 2, and 3. So we're just given these points, and we'll pause it, let you guys try to figure this out on your own, and then we'll go back to it and see if you all can do it. See what your answers are after that. Pausing. So here we go. So this one is a little confusing, and you have to pay attention to the unit blocks here. Each unit block here is worth 2. So although you have some of these dots that end up on half of the unit blocks, they're actually, good points, right? So cosine is opposite over hypotenuse, right? We have to figure out the length of the hypotenuse here. So in order to do that, we got to figure out the length of each one of these, right? So our x values for these ones are -5 and 2. So that means that the length here is 7. Okay, the x values for this middle triangle at M to D is -5 and 9, right? So the distance between -9, 9 minus 5 negative, this is 14. So between here and here is 14. These should be green. Oops. Right, and then the distance between here and here for this longer value, right, is -5 and 13. So this length is 18. Right, you're just figuring out the absolute value between, you can do negative, you can do 13 minus negative 5. Right, that's how you figure out the distance between 2 points. Okay, and then I'm backwards here in my colors, sorry about that. Alright, so here we're looking at our y values. Our y values, difference between 5 and 3, sorry, 5 and 2 is 3. The difference between 8 and 2 is 6. The difference between 7, 9, or is that 9.7 and 2. 9.7 minus 2 is 7.7. Okay. Alright, now I've got to figure out the hypotenuse. Alright, so we're going to do that by Pythagorean's theorem. And, or you know, we could do it with, we could figure out the hypotenuse using sine, cosine, tangent, right? And using the arctangents if we want to. Which way do I want to do it? I'm going to just do it with Pythagorean's theorem. 3 squared plus 7 squared equals, take the square root of that. This is the square root of 58. Oh, still going to use more. The square root of 58. Square root of 58. And then it's going to be 18 squared plus 6 squared. 18 squared plus 6 squared equals, take the square root of 360. This is the square root of 360. Alright, and then we'll take this one is 18. Oh wait, was that 14 squared? That's wrong. This is wrong. This is 14 squared plus 6 squared. This is the square root of 232. There we go. Then we have 18 squared plus 7.7 squared. And we'll take the square root of that. 18 squared plus 7.7 squared. And I'll take the square root of that. And that's 28. 383.29 square root of that. Okay, so that's how we're doing those ones. All right. Or we could do the other way and figure out the tangents. The tangents of the little triangle is 3/7, is 3 over 7, opposite over adjacent, right? Using angle M, right? Angle M. So 3 divided by 7 equals, and then we do inverse tangent. So we know that this is angle M. Angle M is 23.20. Okay, and we'll figure out, make sure that that's the same for the rest of them. Right, 6 divided by 14. Inverse tangent, 23.20. Okay. Tangent is 0.43. 0.43. 0.43. So 0.43 inverse tangent is 23.20. We're doing 20. Okay. So if we know that this is 23.20, 23.26 actually, 23.26, okay, then we can say that if the angles of these, or the line segments, so MC equals, and MR equals, and MK equals. Okay, if I go the if I want to know the sine, so if I go if I say the sine of theta equals opposite over hypotenuse, right? And I know the sine is sine of 23.26 equals the, so I just have to solve for x here, and I'm gonna say I'm effectively flip and flop. So x is going to be equal to 3 divided by the sine of 23.26. Okay, so in each one of these instances, I'm going to say 3 divided by 23.26 sine equals 7.7 which is pretty close to square root of 58. 58 square root 7.26. So anyway, all right, so cosine. So anyway, that's another way you could figure out the lengths of all of these is by doing it this way. But they're all pretty close. Okay, so the cosine of this one here is opposite over hypotenuse. Sorry, adjacent over hypotenuse. So 7 divided by 58 square root equals 0.92. And these will all be 0.92. 6 divided by 232 square root equals, well, that was, sorry, 14. 14 divided by 232 square root equals 0.92, and then 7.7. Nope, 18 divided by 383.29 square root equals 0.92. Okay, and then the sine is going to be all the same stuff too. It's going to be opposite over adjacent. 3 divided by square root of 232, right, which is 0.1. It's like 0.20 effectively. All right, but if I take 232.26 and I put a sine in, oops, it's 23.26, and I put in sine. It's that's not right. Anyway, so if I go 6 divided by 232 square root, it's 0.39, 0.40. I think maybe this was an error. Probably fat figured it. 3 divided by 58 square root equals, yeah, that was an error. Okay, and then so if I put in 23.26 and I put a sine, it's 0.40. Okay, so there you go. Pretty repetitive stuff here, but hopefully you're getting the hang of all this stuff. Learning to use your calculator is pretty helpful. And if you need any help with this stuff, remember using sine and arcsine, arctangent helps out tremendously. Once you know your way around these triangles, it's pretty easy.